There is one application in chapter 6 that relates to the idea of separation, integration, and differential equations. And it's actually a topic that you have a lot of experience with in Algebra 2. I just want to show you how you get there and how these questions are asked. So that topic is exponential growth and decay, which is a topic that is discussed in Algebra 1 and more specifically in Algebra 2. So let's think about what exponential growth and decay actually means. If something is growing or decaying exponentially, it means it's growing at a rate proportional to itself. So the more you have, the faster it grows. The less you have, the slower it grows. The bold words that you see here is the actual mathematical definition of exponential growth and decay. It's that the rate of change of some value y is proportional to y itself. So let's think about how we write that in terms of calculus. So the rate of change of y, we would call that dy over dt. That's how y is changing over time. Is proportional. We use k as the proportionality constant to y itself. So we can make a differential equation based on that wording definition. So to solve that, we have to separate and integrate. So we're going to bring our y over. So it's going to be dy over y equals k, and then we're going to bring our dt over. And now we have it separated. So now I'm going to integrate each side. The y side is going to be a natural log integral, so you're going to get the natural log of y. On the t side, usually we consider it the x side, but now we're working in terms of time. You're just integrating a constant. So if you think about like when you integrate 5, you get 5x, or when you integrate 2, you get 2x. Well, in this case, you're integrating k, and we are in terms of t, so we're going to get kt plus c. To solve for y, you're going to exponentiate. So you're going to get y equals, like we talked about in previous lessons, that c is going to become the coefficient, and you're going to get y equals ce to the kt. This should be the model that you are very familiar with from an Algebra 2 class. C is your initial amount, so just relating it back to algebra. K is your proportionality constant. T is time, often in years, but you can be working with things that are growing with respect to every second or every minute or every hour. And then y is your value after a certain amount of time has gone by. So let's talk about how this is going to show up on the AP test. They are not going to make you go through this whole process of actually finding where this equation comes from. What they do expect is that you can recognize from their wording that it's an exponential growth or decay situation, and then go right to the algebraic formula that you're used to using. So I have 3 examples of where it shows up on AP test, how it's worded, and what the expectation is for you to do. So here's the first one. It's talking about the rate of change of a bear cub and how the rate of change of the weight of the bear cub is proportional to its weight. So this wording right here, when it says the rate of change of something is proportional to itself, should be like alarms going off going, okay, that's exponential growth. So the first thing you're going to write down is your basic exponential growth equation, y equals ce to the kt. Notice we didn't actually have to go through the whole calculus process of separating and integrating. I have to give you enough information to find your K value. So that's going to be a pair of information. So what they tell us is at birth, we weigh 3 pounds, which is going to be your starting value. But after 4 months, we're up to 8 pounds. So I can plug all that information in. I start at 3 pounds. And then my pair of information is after 4 months have gone by, I'm up to 8 pounds. That's going to be enough information to find my K. So I'm going to divide by 3. I'm just going to leave it as 8/3. Then I'm going to take the natural log. Here it just becomes an algebra problem that you're solving. So when you take the natural log, you're going to have the natural log of 8/3 equals 4k, and then you're going to divide by 4. If you want to go to your calculator and get the decimal equivalent of this, you can, but you do want to save it in your calculator. So let me show you what I mean by that. So we're going to take the natural log of 8/3, and then we're going to divide by 4. So that's my K value. It is positive because I'm growing. A positive K value is indicating a growth. A negative K value is indicating a decay. Now I want to take that K value without rounding it, put it back into my equation, and answer the question. So the question wants to know, how much is this cub going to weigh a year later? So I'm still starting out at 3 pounds. That doesn't change. I now have this K value. I'm not going to write it all out. You're welcome to write the first 3 digits. I'm just going to kind of write it like that, meaning I know what this K is. It's on my calculator. 1 year is equivalent to 12 months. Since we've been working with months the whole time, we have to stick with that time frame. And then I'm going to put up my calculator. So I'm going to take my k value and I'm going to multiply by 12. I'm going to take e to that value. So I'm going to do e, and then if I hit second and my answer, my little negative sign, it will take e to that value. And then I'm going to multiply that by 3. Now, oftentimes it will ask you to round to the nearest pound. If there's no indication of how to round, always go 3 places. So after a year, this bear cub is almost 57 pounds. So we're going to say 56.888 or 56.889. Again, often they will give you an indication of how to round. Again, if they don't, go 3 places. So that's how much my bear cub's going to weigh after a year. So here's one that I took straight from AP Classroom to show you another way that it can be asked without necessarily doing quite as much as the last question. So this one says that the population grows according to the equation dy over dt equals ky. That was our equation that we used to set up exponential growth. It's growing at a rate proportional to itself. As soon as you see that, you can then say, well, I know it's growing exponentially, so I can go straight to my known exponential growth and decay model. They tell us that our population doubles after 10 years. So I don't know my initial population, but whatever it is, it's going to be twice as big 10 years later. So I'm going to be kind of generic with this one. I wanted to show you one that is super generic as opposed to the one before that was more specific. So my C's will cancel. The goal here is just to find your K value. We know it's going to be positive because it's growing, but if you look at your 5 choices, they're all positive. So I have 2 equals e to the 10k. To solve this, I'm going to take the natural log of both sides. I get the natural log of 2 equals 10k, and then I'm going to divide by 10. You'll notice based on your answers that this is a calculator problem. So I'm going to go to my calculator. I'm going to type in the natural log of 2. Make sure you close that off, and then hit divided by 10. So my K value, my proportionality constant, is approximately 0.069, which in this case is answer A. So sometimes they will ask you to recognize an exponential growth and do the beginning steps, but not actually do a full problem. And then the last example I have also came from the AP Classroom site. I thought this was kind of ironic given our current situation. So this is talking about an epidemic that is infecting people, and it is growing at a rate proportional to the number of people that are infected. Very much like what we are experiencing, the more people that are sick, the faster the rate of infection, the less people that are sick, the lower the rate of infection. Either way, this is demonstrating an exponential growth situation. So just from that wording, just from the idea that the number of people infected are increasing at a rate proportional to how many that are infected. Plug in what we know. We start off with 1,000 people infected initially, so that's my C value. 7 days later, we're up to 1,200, so that's my T value and my Y value. And then the goal is to figure out how many people are going to be infected 12 days later. You will notice that all your answers are whole numbers because you can't have part of a person. So we're going to divide by 1,000 because our goal here is to solve for K. So I get 1.2. Take the natural log of both sides. I'm going to get the natural log of 1.2 divided by 7. That's going to be my K value. You are welcome to grab a calculator and get that decimal approximation. Just make sure that you don't round too soon. So my K value is about 0.026. Again, it's positive because I am growing. So I'm going to use that K value to answer the question. The question is, what happens 12 days later? So I still have this 1,000 as my C value. I have a K value that I'm just going to store in my calculator, and I have a new time of 12. So back to the calculator. I'm going to take my K value times 12. I'm going to take E to that value, and then I'm going to multiply by 1,000. I cannot have a part of a person, so I am going to round to the nearest whole number, even though they don't mention that. It's hopefully understandable. It's in about 12 days, you're up to 1,367 people, which is C. So that is the application that comes from this particular chapter. It is, because it's an algebra technique you've already done, hopefully an easy application. The calculus piece is just understanding that it comes from a calculus integration, and that's where we get our known formula for exponential growth and decay.